Delta S is the uncertainty in the measurement of a position of a particle along the x-axis, and delta P, which is change in momentum, is this uncertainty in the measurement of linear momentum along the same x-axis. Then the uncertainty principle related is given by. But uncertainty principle actually states that there is high impossibility for you to measure simultaneously the position and momentum of an electron, and likewise the energy and time simultaneously having high accuracy. So in that case, we are relating change in position then change in momentum greater or equals to the Planck constant. So which one actually shows that we are having option B? So which is greater or equals to H? So option B is the answer to that question. So shall we have the next question, question number 22. We are given variables here: low pressure, high potential difference, and low potential difference. So which of these above is true of a conductor of electricity through gases? So for a gas to actually be able to actually move and be able to actually conduct electricity, then we have low pressure and likewise high potential difference. Low pressure and what? High potential difference, we actually are bound for it. So in that case, we have 1 low pressure and 3 which is high potential difference. So 1 and 3 is the answer to that question, which we have as option A. So we'll go to the next question. So for this next question, we have 118.8 centimeter square surface of the copper of a voltammeter is to be coated with 10 raised power minus 3 meter thick copper of density 9 multiplied by 10 raised power 3 kilogram per meter cube. Then the question now, how long will the process run with 10 ampere of current at constant current? So what we have to do here, we use the idea of the first law of Faraday, where we have mass equals to Z, then what? Q. And that same Q again will still give us current multiplied by time. Therefore, we can have mass equals to Z, I, then T. But how do we now get this mass? Then we go back to the idea of density equals to mass over what? Volume. But volume again will give us area multiplied by thickness. Then going back to the question, we have the area given in terms of centimeter square, which we have to convert to meter square. So what we have to do for the area now, we have 118.8 centimeter square. So we convert it to meter. So 118.8, that is divided by 100 multiplied by another 100, because 1 centimeter, 1 meter is equivalent to 100 centimeter. So we have it in meter square. So for volume now, we now have area multiplied by the thickness. In that case, we can have 118.8 over 100, that is 10,000 now, multiplied by the thickness, where we have it as 10 raised power minus 3. So this same again, this same volume can still give us 118.8, then divided by 1 times 10 raised power 4, multiplied by 10 raised power minus 3 here. So in that case, if I'm bringing this coming up, I'll be having volume 118.8 multiplied by 10 raised power 7 in meter cube. But then I want to convert this to mass. So I'll go over it again, that my mass, from what we have here, mass will give us density multiplied by volume. So the volumes already, we have it. So density now multiply it 9 multiplied by 10 raised power 3 multiplied by 118.8 times 10 raised power 7. That gives us the mass now. So coming to substitute in our initial formula. So this 9 multiplied by 10 raised to power 3 multiplied by 118.8 times 10 raised to power 7 equals to, we are given the electrochemical equivalent already, which is 3.3 multiplied by 10 raised to power minus 7. Then multiplied by the current given, which is 10. Then we are looking for time. So making time subject to the formula. So we have 9 multiplied by 10 raised to power 3 multiplied by 118.8, then divided by 3.3 multiplied by 10 raised to power 7 times 10 indeed. So this should be 7 indeed. So at the end of the day, we are going to have this time converted to minutes as 5.4 in minutes. So we have option B as the correct answer there. So next question. So for the next question, we are given at what frequency will a capacitor use capacitor of 2.5 microfarad used in a radio circuit have a reactant of 250 ohms. We now connect that frequency and likewise the reactant and as well as the capacitor. And the reactant here will give us by formula 1/2 pi F then C. So for that, reactant is given as 250. Then look at all answers given in terms of pi. So we don't need to get the value of pi. So we have 1/2 pi. Then we are looking for the frequency, which is unknown, times the capacitor now, 2.5 times 10 raised to power minus 6. So for me, I will make this 10 raised to power minus 6 now coming up, where it now becomes 10 raised to power plus 6 indeed. So 250 will still remain what we have on the left hand side. So here I will have 10 raised to power 6, which is the same thing as 1 million. So 2 multiplied by 2.5 will give me 5 of pi. So I will have to cross multiply to get the value of F indeed. So if I cross multiply, this will give me 250 multiplied by 5 of pi then F equals to 1 million. Because 10 raised to power 6 is the same thing as 10 in 6 places. So 1, 2, 3, 4, 5, 6. So 250 multiplied by 5 will give me 750 in terms of pi, and the frequency equals to 1 million. So I want to make F now, so the formula. So I will have 1 million over 750 then in terms of pi. So I will have 800 over pi as my answer. So that gives option what? A. Option A. So shall we now go to the next question? So for the next question, from the generating station to each power station is transmitted a very high voltage so as to reduce. So we are going to have eddy current. So eddy current has to be reduced. So that answer comes as option what? A. But that effect of eddy current as well can be overcome by laminating the core using a softer wire. So the answer there is option A, eddy current loss. So the next question goes, so for this one we have the question. A circuit has an area of, let's have the parameter written down, area is 0.4 meter square and consists of 50 loops. That's the number of loops now, 50 loops indeed. So if the loops are twisted and allowed to rotate at constant velocity, so velocity of V, where we have it as 10 radian per second, then we are having magnetic fields, or we call it magnetic flux indeed, which is B there. We have it as 0.4 Tesla. Then the question now says the amplitude of the induced voltage, or we can have it as the induced force. So the induced voltage or the induced e.m.f again, electromotive force indeed. And that will give us the product of the magnetic flux, then multiplied by the area, multiplied by the velocity, and multiplied by the number of turns. So the magnetic flux now we have it 0.4 multiplied by 50 multiplied by 10, then multiplied by 0.4 again. So if you have to use a calculator and multiply, you are getting 80 as the answer. So 80 voltage. So which is option A. Option A. So we go to the next question. So Lenz's law is a law of. This Lenz's law is also known as Faraday law of electromagnetic induction. So it's a conservation of energy. And it states that what we have in an electromotive force will actually change in direction as to oppose the motion causing it. So the answer to that question will come as energy. So Lenz's law is a law of conservation of energy, not electric current, not momentum, not electrical charge indeed. So option D is the answer. Then we have the next question. So for this next question, let's see how we go about solving this. A transformer which can produce 8 voltage from a 240 voltage AC supply. That AC comes as alternating circuit supply. We have efficiency, will give us power outputs over the power inputs. Then for the output comes as the secondary, then the input comes as the primary. But this power again will give us current multiplied by velocity, potential difference. In that case, we can have efficiency giving us current in the secondary, then potential difference in the secondary as well, over the current in the primary, multiplied by the current, the potential difference in the primary, expressed as percentage. So in the question, we are given the efficiency already, which is 80%, making 80 over 100. So the current in the primary, let's check it out, the current in the primary. So we are asked to calculate the current in the primary, which is unknown. Then the current in the secondary, now we have it as 15. Then likewise, the voltage, now we have it as 8 over. So the voltage from the primary, we have it as 240. Then we are looking for the current. So multiply by the 100%, which is 100 over 100 now. So what I will have to do is to cross multiply, where I have 240 multiplied by current in the primary. So equals to, this is 240 multiplied by current in the primary, then multiplied by 80 equals to, here I will have 100 multiplied by 15 multiplied by 8. So if I now make IP solve the formula, which is current in the primary, I will have 100 multiplied by 15 multiplied by 8 over 240 multiplied by 80. Then 8 can go in 80 10 times. Then this 10 again can go in 100 10 times. So I will now be left with 10 multiplied by 50, which will give me 150 over 240. So if I divide this 150 by 240, I'll be having 0.26, that is 0.625 now in ampere. So that gives option A indeed. So shall we now go to the next question? So for the next question, the core of an efficient transformer should consist of laminated pieces of metal. For the answer to this question now, we have to reduce the heat produced by reducing the effect of the eddy currents. So D comes as the answer to that question. So the next question goes, next question. So a moving coil galvanometer, but galvanometer on its own is an instrument that can measure both current and voltage with high accuracy. So it can combine the measurement of current as well as the case of potential difference with high accuracy. Then in this question we're given a moving coil galvanometer of resistance 300 ohms. Then we have the current given, which is 1 milliampere. The same thing as having 1 divided by 1000. That will give us 0.01 in ampere. Then the resistance of the shunt that is required to convert the galvanometer into a 3 amperes ammeter is. So from Ohm's law, where we have V equals to IR, as we have current in the galvanometer multiplied by the resistance in the galvanometer, we also have the current in the shunt multiplied by the resistance in the shunt as well. So in the question, we have the current in the galvanometer as 0.001. Then the resistance is given as 300 equals to, we don't know the resistance in the shunt. But then, how do we now get the value of the current in the shunt? So the current given to be converted is 3 minus the current that we have in the galvanometer, which is 0.001. Then multiply now by the resistance in the shunt. So if you actually multiply this, you can actually change this one again to fraction, where we have 1 over 1000 multiplied by 300. Then taking away 0.01 from 3, we have it as 2.99. Then Rs now for resistance in the shunt. So this cancel out this also cancel out this. So what we are left now is 3 over 10. That will give us 0.3 equals to 2.99 of resistance in the shunt. So making that resistance in the shunt now subject to the formula. So we have it is 0.3 over 2.9, then what, 9. So the answer now will give us is 0.1 here in ohms, which is option C there. So we have option C. So we now move to the next question, where we have the instrument that measures both. You see, that measures what? Both alternating current and as well as direct current. We have it as an ammeter that actually measures current. But we discovered that we have a moving iron ammeter and likewise a moving coil ammeter. So the one that can actually be used to actually measure alternating current and direct current is a moving iron what? Ammeter, which gives us option B. So that is the answer to that question. Then we go to the next question again, where we have two long parallel wires X and Y carries current of 3 ampere and 5 ampere respectively. If the force experienced per unit length by X is 5 multiplied by 10 to the power minus 5, then the force per unit length experienced by wire Y is. Then we have to relate this our force to current. And here, force is actually inversely proportional to current. In that case, if I remove sign of proportionality, I will have what? K over what now? Current. So if I now make case of the formula, I will have K equals to F, then what? I. So I will have F1, I1 for X, then F2, I2 for Y. But in the question, we're giving 5 multiplied by 10 to the power minus 5 for the force per unit length for X. Then, they now ask what the force per unit length experienced by Y is. But the current in X is 3. So, we have the current in Y to be 5. Then we are now looking for the force per unit length in the second wire Y. So, on both sides now, this 5 can cancel out this 5. So we are now left with 1 multiplied by 10 to the power minus 5 times 3. So equated to F2. So 3 multiplied by 1 will give us 3. Then multiplied by 10 to the power minus 5. That gives us the force per unit length for value of Y. So which option actually corresponds to that? We have it as option D. So the answer to that question comes as D. So move to the next question. So this one will go back. This question will come under relative density. Then the mass of specific gravity bottle, that is the empty bottle now, we have it as 15.2 grams. When it is actually empty, it is 24.8 when filled with kerosene and 27.2 when filled with distilled water. Discover that kerosene and water, they are both liquids, but they are different liquids based on their density. So for us now to get the relative density of the kerosene, which is the liquid now, so we have RD here. So the empty, so we are going to have relative density of liquids over relative density of water. So for this now, what is the density of the liquid, which is the kerosene? We have it as 24.8 minus the empty bottle, which is 15.2 over what we have as 27.2 minus 15.2 as well. So if you are now taking away 15 from 24.8, so we have it as 9.6. Then taking away 15.2 from 27, we are going to have it as 12. So if you now divide this 9.6 divided by 12, we are getting the value as 0.8. And mind you, relative density has no unit because it's a ratio of two densities. So the answer to that question will come as 0.8, which is option D. So shall we now move to the next question, where we have light of energy 5 electron volts fall on the meter of work function, and that work function has a definition as well. That is the minimum energy required to remove electron from the surface of a metal, minimum to say. An electron are liberated. Now the question now, the stopping potential is. So how do we now relate that work function and the energy given, and likewise the stopping potential that we have here? So when we hit the surface of an electron, of a metal, electron is now being liberated. That electron liberated will now gain energy in form of kinetic energy. So we have the energy now equals to work function plus kinetic energy. So for this, the energy given is 5 electron volts. The work function is 3 electron volts. Then this same kinetic energy can be in electron volts. So for us here now, if you're now taking that 3 electron volts now to the left hand side, showing that we are collecting the like terms. So we have 5 electron volts minus 2 electron volts equals to electron volts here now. So 5 minus 3 minus 3 here will give us 2 of electron volts equals to EV. But then we want to get the value of V. On both sides now we can cancel out the electrons. So our stopping potential now V will give us 2 of voltage. So the answer to that question comes as C there, which is 2 volts. So shall we now move to the next question? So the next question goes this. The process of energy production in the sun is never nuclear fusion, where we are bringing 2 nuclei together to release what? Heavy energy. Then the case of fission, we are actually breaking down the nucleus of a radioactive element, giving us daughter nuclei. Then if you are saying we have radioactive decay, we are breaking down radioactive element over time again. Then for the process of energy production in the sun, we have it as electron collision, which is option D as the answer to that question. We are asked to actually calculate the wavelength of the threshold frequency. Then we have this formula that I can actually work for it. So work function will give us the product of the Planck constant and threshold frequency. But from this again, wavelength the velocity will give us frequency multiplied by wavelength. So making frequency subject the formula here, we have velocity over the wavelength. Therefore, work function again will give us Planck constant multiplied by the velocity over wavelength of the threshold their frequency. So if I substitute the value of the work function, which is 6.4 multiplied by 10 raised to the power minus 19. So for the Planck constant, 6.63 times 10 raised to the power minus 34 multiplied by 3 times 10 raised to the power 8 over the wavelength. So making wavelength under the formula now, I have 6.63 multiplied by 10 raised to the power minus 34 multiplied by 3 multiplied by 10 raised to the power 8 over 6.4 multiplied by 10 raised to the power minus 19. So multiplying the numerator and dividing by the denominator, we arrive at 3.09 multiplied by 10 raised to the power 7 in meter, which is option A. So the answer is option A now. So we'll go to the next question. So for the next question, a gas will serve as an electric conductor under two conditions. And the conditions are, we have pressure and likewise potential difference. So where we are going to have low pressure and high potential difference. So we'll go and check the options where we have low pressure and high potential difference, which give us reduced pressure and reduced potential, no, but we can have reduced pressure and likewise high current, because current will eventually result from difference in potential. So the answer to that question will give us option B, reduced pressure and high current. So we'll go to the next question. The gas carrier in gases are just like we have in a conductor. In a conductor, we have electron. In electrolytes, we have ions. Then in gas conductors now, in gas conductor, we'll be having holes. Then discover that we have electrons and holes. So electrons and holes. So which give us option what now? That is option B to say. So we have electron and holes. So next question. So for this next question, we have a current of 0.5 ampere flowing for 3 hours deposits a mass of 2 grams of a metal during electrolysis. The quantity of the same metal that will be deposited by a current of 1.5 ampere flowing in 1 hour is. So what we have to do, we go and check with first law, Faraday's first law. So we have M equals to Z, I, then T. But in the question, we don't need electrochemical equivalent. So we can make it subject to the formula where we have M now equals to Z equals to M over IT. So as we have M1 over I1, then we can also have T1 equals to M2 over I2, then T2 to say. So with what we have here, the mass initially was 2 grams. Then the current flowing is 0.5. Then the time for it, we have it as 3 hours. So don't need this mass that will be liberated where we have the current of 1.5 and the time now to be 1 hour. So 0.5, that is 0.5 now, that is half of 3, will give us 1.5. Then we are looking for mass, which is unknown. So 1.5 multiplied by 1 also give us 1.5. So on both sides now, 1.5 will cancel out. So the mass now will give us 2 grams. So the answer to that question will give us 2 grams. So which is option C. Option C to say. Then we can go to the next question where we have 4 cells. The cells now, we can have cell A, cell B, cell C, then cell D. And each of them has 1.5 volts as their electromotive force. and internal resistance of 4 ohms are connected in parallel. What is the effective EMF and internal resistance of the combination? So when these are connected in parallel, the cells now A, B, C connected in parallel, they will have the same potential difference, so which is 1.5 in all for the potential difference. But for the internal resistance now, we use the formula 1 over R. So since we're having 4 cells, 1 over R1 plus 1 over R2 plus 1 over R3, then plus 1 over R4 to C. So 1 over R now, so we have 1 over 4 plus 1 over 4 plus 1 over 4, then plus 1 over 4 as well. So with what we have here, so if you are making the LCM now, what is the LCM of 4 and 4 and 4? That will give us 4. So 4 goes in 4 one time times 1. So the same thing applies to others, 1, 1, 1. So if you add up 1 plus 1 plus 1 plus 1 will give us 4 in this. So 1 over R on its own, we have 4 over 4. So if you cross multiply, we have 4R equals to 4. Then what do we have to do to get the R? Divide side by 4. So R will give us 1 of ohms. So the answer now will give us 1.5 for the electromotive force, but 1 for the internal resistance. So which is option D there. So we have it as option D.